Hello, so this is the first of a few videos that talks about linked list. So in this video, we're just going to do a short intro and we're going to talk about the add operation. All right, so linked list is a data structure. Just a quick review what a data structure is. According to Wikipedia, data structure is a collection of values. And so when we say collections, that means we're storing multiple values, right? It's not just a single integer, it's not just a single string, but a dozen or hundreds of thousands, millions of them. Okay, and the relationship among them. So that kind of means, maybe they're sorted, right? Maybe the number zero comes before the number one or the other way around. So there are some relationship between all these multiple values. And then finally, the kind of thing that can be done to these values. And commonly, they include insertion, adding a new number, removing a particular string, or looking up something. So that's what a data structure is. Now, array and linked list are two of the most fundamental data structures, and you are expected to have studied them either in 3B or in maybe other intro to Python or computer science classes that you have taken before. And among the two of them, linked list is probably the more versatile one, and it's a very, very well studied topic in computer science, and that's why we talk about it first. And as a matter of fact, I went to UC Berkeley, and in our introduction to computer science class, CS61A, they use a language called Lisp, or short for Lisp processor, and it's designed entirely on the idea of linked list. And like I said, that used to be the main language that was used in the CS61A. But I think nowadays they changed it to something else. But anyway, so we'll study linked list in a little more depth for a week. So before we embark on that, it's just kind of worth pointing out that we are not studying the Python list, the Python built-in list. Now, Python has different implementations, at least in terms of the one of the most popular implementations, CPython. List is actually not much like a linked list. It's actually more like an array, but it's a variable length array, so it does have characteristics of a linked list. Anyway, it's so just want to point out we're going to study linked list, not the Python linked list. And also a tip for all of you is when you're studying linked list, data structures in general, it's actually very important or very useful to draw pictures. So get a stack of paper, get some get a pencil or a pen, and start drawing pictures. Okay. And speaking of that, so here is a picture of a linked list. It should be reviewed. There shouldn't be anything new here. So linked list at the very fundamental level, the nodes. Linked lists consist of nodes, and the nodes, most of implementation of linked lists, the nodes would contain at least a next pointer that points to the next node, and then obviously also the data that the node contains. And so all these nodes are kind of linked together. That's why it's called linked list. And now in terms of the linked list itself, we always need access to the very first node in the list. So, and usually that's called the head, and we'll continue to call it the head. And then the last node, the next pointer in the last node is usually points to nothing. I guess in case of Python, it will point to none. And in terms of the pictorial representation of none, this is kind of the electrical engineering symbol for ground, and that usually means it's pointing to nothing. So that's for the last node. Okay, so in terms of the code, here is a linked list node Python class. I've typed it out here. Shouldn't be anything unexpected here. Hopefully, when you allocate a node, you should give the data. We'll store the data in a underscore data private attribute, and then the next pointer we should initialize it to none, and then we have We define the data property, we define a setter, we define the next property, and we define a setter. We define a string that just done the string method that just print out the data, and the reprieve done the reprieve method, which hopefully you remember what it is, but if you don't, it's basically a string for programmers, so it can shows a little more information for debugging, right? So in this case, we'll also show the ID of the next pointer. It might come in handy at some point. So that's a linked list node. Okay, so the next thing we want to define it would be the linked list class itself. So as we showed earlier, doesn't really matter what your implementation of the linked list is. You almost always want at least a pointer or reference to the very first node in the linked list. So we'll start with the initializer. We'll start with the head, private attribute head, and that head, now when we first started, the list is empty, right? So there's nothing in the head, or the head is pointing to nothing. Also, do we need a property? Do we need a getter for the head? Well, usually no, because we don't want to expose the head to the client code. I mean, there's really typically no reason to do that. So we won't do that. However, another one useful property would be actually the number of nodes or number of data in the list. And we're going to call that size. And when we first started, again, it's empty. The size is 0. Now, when we actually want the size, one way is we can actually just count the number of nodes when we need the size, right? But that typically takes a while, especially if your linked list has, I don't know, 1 million nodes. That would take a while to count all of them. So we'll just check the size as a number so that we can quickly return the size. And now the size is something that the client will probably want, so we'll make a setter for it. So we'll just make a property size and return size. All right. Now it's also in Python there is a standard way of getting the size of any sort of user-defined class, and that is actually by defining the dunder length method. So we'll also support that. It's just a nice thing to do. So, and in this case, we'll just, for the dunder length, we'll just return the size. Okay, so we've written, let's say 30, 40 lines of code. Even though they're very basic, we really should be testing it already. So I actually created a test file already. And I'm actually going to, well, I'm not going to, I'm going to test just the initialization. So in test init, oh, and by the way, here's another thing I just kind of want to point out is you kind of notice when I write this test file, I am using a camel case. Python methods should really be a snake case, but I'm using camel case because unit test itself uses camel case. So either one's fine. I'm not going to be picky on that. So pick what you're comfortable with. I'm just going to stick with the camel case. Okay, so I'm going to allocate a linked list in my test, and yes, this test is just the test initializer. Okay, so I'm going to allocate a linked list. I am actually going to check a few things after I do the allocation. So I'm going to make sure the head has data. Well, actually, sorry, no, sorry. The head does not have any data. I want to make sure head is pointing to none. So I'm going to say is none, and the linked list, the head. Now, usually it's not a good idea to reach into private attributes of an instance of a class, but for test code, I believe it's acceptable, and so it's okay for test code. But for client code, we really should not do that. Okay, so what else can we check? we can check the size. So the size should be 0, right? So we get the size. And then also let's make sure the length also works. So we'll do length. And let's just run it. And there, good. It works. Okay, so that's the test. Now again, even though it's very simple test, if nothing else, we really should be making sure whatever, when we change the code in the future, we don't change the very basic behavior. And that's why even for something so basic, we want to write some simple basic test. Okay, the next thing is we want to add operations to the linked list, right? And as we kind of mentioned, things we probably would like to do is add some data, remove data, look up some data, and iterating, like retrieving everything in the list. So we'll do the insertion or add first, because if the list stays empty, it's really not that useful. Okay, so in terms of adding data to a linked list, the first question we want to ask is where in the linked list we want to put the data to. Are we putting it at the head, the very first one? Are we putting it at the end, or somewhere in the middle? As a first attempt, it's reasonable to let's keep things simple and add the data to the head. So now, since we're putting things always at the head, regardless of the value of the data, will most likely, in a random world, we'll end up with an unordered linked list, which is fine for now. And also, just want to point out, if you're adding things to the head, then this linked list kind of works like a stack, right, where the head is the top. So anyway, let's see how we want to write add to head. So I'm going to define add to head self and a piece of data. Now, what is the first thing that we want to do with a piece of data? Well, when adding a piece of data, we have to put the data in a node, right? Because that's really what exists in a linked list. So we're going to create a new node. We're going to just create a linked list node and give it a piece of data. Okay, and this is what this is doing. Now, assuming we kind of have an existing list, head pointing to some number of nodes, we want to put it in the head. What is the next step? Well, the next step is, we want to end up with the picture, the head points to the new node, and then the new node points to the old head. So let's point the node dot next would be the current head. Okay, that would be this step here. And then finally, we want the current head to point to the new node, and that would be like that. That means we do self head equal to the new node, and is that. So let's test it to make sure that it works. Okay, so how are we going to test this? Well, again, we are going to create a linked list first, empty linked list. Now we're going to do add to head. Let's just add the number 1. What can we check after we add the data 1? Now, so the first thing is we probably can make sure that whatever's at the head is the data is the number we just added, right? Number 1. So let's do that. Let's run it, and still works. That's good. Next thing we may want to assert is, okay, the head's data, we check the head's data, we should check the head's next, right? We should check the next should be none, is none. So the head's next is none. So that's that, and that's good. Okay, now one more thing, we just inserted a piece of data into the head, so the size should now be 1, right? So let's equal the size is 1. And then let's do the length. And really, I shouldn't be calling all these ones. It's getting confusing. So why don't we do that? We're inserting the value 10, and the size should now be 1. And okay, at the head, the size is expected to be 1, but it's 0. And why is that? Because I did not increment the size. Okay, so size should be incremented. So let me run this again. And good. Okay, so great. So far so good. Now, this is only adding one piece of data. We really should make sure that add to head works for multiple pieces of data. Okay, so and I actually want you to do that. So why don't you update the test? Make the test. You can actually just modify this existing test and add a second number to the list. Okay, and make sure the first 2 nodes of this list contain the right data, and then the next attribute of the last node is none, and also really the size should be 2 now. Okay, so pause the video, give that a try. All right, so I am actually going to do that as well. So I am going to add a piece. I'm going to add 20. And what I'm going to assert is, okay, now you have to be very careful because 20 is now at the head. So the data at the head is expected to be 20. Okay. And the next pointer, the head's next data would be the one that was there before, and that would be 10. And finally, the next head's next dot next is the one that is none, because that would be the last one. And now the length should be 2 instead of 1. Okay, so I kind of did this in my head. I really should not have, or if because I can, because I've done this a number of times, and hopefully that works. Make sure it works first. Right, it does. Now, if you don't see this immediately, you should draw a picture to what the linked list should look like now, and make sure all of these asserts actually do make sense. So that's good, and I really should be running both tests to make sure I didn't break anything in the init. I should not have. So both of my tests pass. So that's good. So far so good. Okay. Now, as you can kind of see, I only added 2 pieces of data, and the test is already getting complicated. There's 7 asserts here. So imagine if I want to add another piece of data, this it can get very long. So there's probably a better way to do it, and that is, so if we can easily iterate over all the data in the list, right? If we can read all of them back, then it's much easier to verify its correctness. And also, iteration over all the data in the linked list is going to be a very useful operation anyway, right? So iterating, I assume you have done iterating over a linked list. That's a fairly common thing to do, and that's just basically involve following a bunch of next pointers. Now, in terms of how exactly we allow the client code to iterate over things, you probably have done some sort of traversal before, linked list traversal. Now, for us, for our implementation of linked lists, and also at least in the binary tree in a couple of weeks, we'll actually do it the more Pythonic way, using iterables and generators, which we'll talk about in another video.